In this video, we will be solving exercise 1A, question number 4, 5, 6, 7, and 8 from the new syllabus mathematics book 1, updated 7th edition. The statement of question 4 is as follows. Find the square of the following numbers. Now before solving this question, let's define the square of a number. In algebra, the square of a number can be calculated by multiplying a number or integer by itself, and the result is called a square number. For example, the square of the number 3 is 3 times 3 is equal to 9. The square of the number 4 is 4 times 4 is equal to 16. And the square of the number 5 is 5 times 5 is equal to 25. It is important to note that square numbers are always positive, because when we multiply a negative sign by itself, it results in a positive sign. For example, the square of negative 4 is negative 4 times negative 4 is equal to positive 16. So we can say that 16 is a positive square number. Now let's find the square of the given numbers by simply multiplying these numbers by themselves. I will start with the first number, which is a 42. Square of the number 42 is 42 times 42 is equal to 1764. Square of the number 51 is 51 times 51 is equal to 2601. Square of the number 48 is 48 times 48 is equal to 2304. Square of the number 92 is 92 times 92 is equal to 8464. Square of the number 86 is 86 times 86 is equal to 7396. Square of the number 75 is 75 times 75 is equal to 5625. Question number 5. The sum of the squares of two positive whole numbers is 794. If one of the numbers is 13, find the other. Now in this question, we are given the sum of the squares of two positive whole numbers, which is 794. And one of the number is 13. To find the other number, let's consider the other number as x. So let the second number be x. Now, as per the condition of the question, the sum of the squares of two positive whole numbers is 794. Therefore, the square of the first number is 13 square, and the square of the second number, which we assumed as x, is x square. The sum of their squares is 13 square plus x square is equal to 794. Now we have calculated the equation 13 square plus x square is equal to 794 as per the condition of the question. It is time to solve this equation in order to find the value of the variable x. So I'll start from the left side. The square of 13 is 169. So the equation becomes 169 plus x square is equal to 794. To find the value of x, I will subtract positive 169 from both sides of the equation to eliminate it from the left side. This will help us isolate x on the left side of the equation. And subtracting 169 from 794 on the right side gives us positive 625. Now it's time to eliminate the square of x. So let's take the square root of both sides. 625 is a perfect squared number, and its square root is 25. We have calculated the value of the variable x, which means we have found the second number 25. Therefore, the second required number is 25. We can also verify our result. The square of the first number 13 is 169, and the square of the second number 25 is 625. The sum of their squares is 794, which satisfies the statement of the question. Statement of question 6 is as follows. Find the difference of the squares of 65 and the square of 45. It's a very simple question to solve. Let's find the difference between the squares of these numbers by first squaring them. The square of the number 65 is 4225 and the square of the number 45 is 2025. The difference can be calculated by subtracting 2025 from 4225, which is 2200. And that's the final answer. Question number 7. Estimate the value of each of the following. Now, one common feature of this question is that all the numbers provided are non-perfect squares. Similar to perfect squares, we can also determine the square root of non-perfect square numbers using the long division method. However, for this question, I will use a scientific calculator to find their square roots. Now, first part from this question, square root 66. The square root of 66 up to 3 decimal places is approximately 8.124. Now, rounding off this number to the nearest whole number gives us 8. Therefore, the square root of 66 is approximately 8. The square root of 8000 up to 5 decimal places is 89.44271. Now, if I round off 89.44271 to the nearest whole number, it gives us 89. Therefore, the square root of 8000 is approximately 89. Remember, you can also round off these numbers to 3 or 4 decimal places. It's up to you. Remember, 89.44271 will remain 89 after rounding off this number to the nearest whole number, because the digit after the decimal point is 4, which is less than 5. If the digit after the decimal point is 5 or more than 5, then 89 would become 90. Moving on to number 3, we have the square root of 2186, another non-perfect square number. The square root of 2189 rounded to 3 decimal places is approximately 46.755. In this case, the digit after the decimal point is 7, which is more than 5. Therefore, after rounding off the number 46.755 to the nearest whole number, it becomes 47. Therefore, the square root of 2186 is approximately 47. The square root of 7305 rounded to 3 decimal places is approximately 85.469. Therefore, after rounding off the number 85.469 to the nearest whole number, it becomes 85, which means the square root of 7305 is approximately 85. Question number 8. Use a calculator to evaluate each of the following, leaving your answer correct to 4 decimal places where necessary. The first part of this question is 7 square minus square root 361 plus 21 cube. To evaluate this expression, first let's find the square of the number 7, which is 49. Then find the square root of 361, which is 19. Next, I'll calculate the cube of 21, which is 9261. Now, I will subtract 19 from 49 to get 30. Finally, I will add 30 and 9261 to get 9291. Therefore, the final answer is 9291. The second part of this question is square root 555 plus 5 square whole divided by 2 cube times cube root of 2222. Now, our first step is to calculate the square root of 555, which is approximately 23.5584. Now, let's find the square of 5, which is 25. For the denominator, we will calculate the cube of 2, which is 8, and then find the cube root of 2222, which is approximately 6.0550. Next, we add the numbers in the numerator and multiply the numbers in the denominator. We get 48.5584 divided by 48.44. When we divide the numerator by the denominator, we get approximately 1.0024. According to the question's condition, we round our final answer to the nearest 4 decimal places. Therefore, our final answer is 1.0024. Moving on to number 3, we have square root of 4 cube plus cube root of 4913. Our first step towards the solution is to find the cube of 4, which is 64. Then find the cube root of 4913, which is 17. Next, I will add the numbers 64 and 17. Their sum is 81. Since 81 is a perfect square number, therefore square root of 81 is 9. That's our final answer.